I am live. Still going to wait a couple more minutes. There we go. Maybe. Try that again. Click that button. I don't want a tutorial right now. There we go. All I want is, I just want the chat. All right, I'll go ahead and start because there's plenty to go. All right, so welcome everyone. So real quick. There we go. So first, I want to thank our sponsors. Slingshot provides the space, and the tech system provides the food. There's plenty of pizza, so definitely dig in. Of course, I learned Kyle has special. He's got special ways to get really good prices on pizza. So if you really like pizza, you want to be Kyle's friend. Is what I heard yesterday. All right, so upcoming meetups. So next month, we've got Mike Eaton coming down from Columbus. He's going to talk about Spectre console. Actually, I've been fooling with Spectre console. I can't say it. Spectra console recently, and it's pretty cool. I'm actually I'm looking forward to seeing what he's got to say. And then sure enough, in July, actually, I got to verify if he's coming into town or he's going to be doing virtual. But we'll have David Giard. He lives in Chicago, and I realized today we didn't discuss whether he was actually coming in or not. But either way, we'll have David. He's going to talk about empowering AI. And then in August, I'm going to be presenting again, unless I might find someone else to do it. But I'm doing a season of AI. This is a special thing that Microsoft's trying to do. They realize that, as event leaders, we're always straggling for content and everything. So this is their first one where they're going to try to do like quarterly releases of talks that to make available. So, and supposedly we're going to have some swag. I have no idea what that swag will be, but supposedly we'll have some swag for that one. All right, so that's upcoming LouDotNet Azure meetups. So June. So because you can't get enough of me, I will be speaking. So I'm going to be talking about Azure Functions, which is basically, if you don't know about Azure Functions, it's a way to have basically little pieces of code that run out in the cloud, trigger based and everything. Sure enough, this week, because this week is build, they announced Flux consumption. I've been playing with Flux consumption for 6 or 7 months now. Really, really cool. And Azure Functions was already very, very scalable. Now it's crazy scalable, right? And it's so that's what we'll be talking about in June. As far as other meetups and such, here's a collection of things I picked that are within driving distance. So Scenic City, that's in Chattanooga at the end of June. Cincy Deliver, which honestly is the best priced one of all these. So that's obviously in Cincinnati. So it's a day full of things. And then DevUp St. Charles, which is right next to St. Louis. So that's a 3-day event. So some great events. I will be at all three. Actually, I help run Cincy Deliver, but I will be at all three. All right, it's Brick House Tavern. I never can remember what it's called. So sure enough, after the presentation, some of us will head over to Brick House. Definitely, everyone is invited. Talk more about the topic tonight. Talk about whatever. Right? It's just a way to hang out afterwards and socialize. All right. So announcement. I created a new GitHub repo for the meetup. So I don't know why I didn't think about this before, but so speakers come, they do their presentations, and usually they'll email the list group, hey, here's a link to my presentation and everything. Now, we'll actually have a dedicated place. So, again, always make it optional for speakers to provide their slides, but, they'll be able to do that. So, TaleLearnCode / LouDotNet. It's got the meetup schedule. It's got, we'll have slides, demos. So, like the slides I'm doing right now, these are already up on there, and so forth. I do have created a resource page. Right now, it's just a couple things because I was in a hurry. But I do, definitely, if you've got some resources to add to that, it's open source, right? So go forth. All right. So tonight I'm going to talk about essential software design patterns. So for those who don't normally come here, I do not normally do all the presentations. It might seem like it after I just said I'm doing this presentation, that presentation, but sure enough, tonight I am speaker for a couple of reasons. But I will say I got a big caveat about this talk. So the way how I build talks is I build talks and I just write a bunch of slides. It is not unusual. I have to cut content that I wrote too much. I write enough talks that I'm actually good enough that I write too much content and then scale it down. I will say this right now. This has not been scaled down. So, and I actually have no idea how long it would take to give this talk. So we're going to see. We're going to see that together. We might end up just saying, hey, let's skip some slides and everything. Like I say, all the slides are available on GitHub and my demo code, right? So I'm going to be talking about software design patterns. So for every design pattern we're talking about, hopefully I'm going to talk about 6 design patterns. And all 6, I wrote a demo application. Very simple, just to get the point across. All right. So for those who have not met me before, my name is Chad Green. I am the senior software architect at a company called Jasper Engines. It's one of those things, if you've heard of us, you know exactly who we are, but most likely you haven't heard of us. We rebuild engines of all types, right? Cars, trucks, boats, the tugs at the airport, right? So we do all kinds of stuff. Really interesting work we do there. I am a Microsoft MVP. So what that means is, basically, it means is Microsoft recognizes that I go out and speak a lot and so forth, and run events and get a lot of nice benefits. Like I said, flex consumption I was talking about. I was able to see that. Actually, I first heard about it last year, last March, and then September of last year, I got to start playing with it. So, but anyway, so I'm that. All right, but we're going to talk about design patterns. So design patterns, what are we talking about? Well, basically, these are reusable solutions to common problems. So the idea of, hey, because honestly, most everything we do in software, we've probably already done it before, right? Probably done it in a different way, doing different data, but there's, a lot of the actual basis of the code, right? There's not that much difference with what we're doing. And design patterns are basically, hey, this is a normal pattern we see. And sure enough, now, normally we talk about design patterns, we're talking about good patterns, right? There is a philosophy of anti-patterns, right? So those are things we do that are not good, right? I'm just all of a sudden drawing blanks on anti-patterns. There's quite a few of them, but I don't know. Anyone got an idea of an anti-pattern? Because I'm completely drawing a blank. Thanks. But anyway, doing the wrong things, right? So they're reusable, they're best practices, and they're the building blocks, right? So by using patterns, I could say, okay, I need to build this type of solution. Well, okay, here's what we need. Here's what the requirements are. Oh, okay, well, we'll probably implement the factory pattern to do this and use the strategy pattern because we need to make changes and act on this kind of stuff. Now, with that being said, it is very common, especially in my role as an architect. I know plenty of architects who quickly will say, oh, okay, well, we're going to use this pattern, that pattern, this pattern, this pattern, right? And I'm like, okay, first off, how many patterns are you going to try to use at one time, right? But also, not everyone understands what you say when you say, oh, we're going to use a state pattern for this, or we're going to use that pattern for that. I mean, half the time I can't remember all these patterns, right? One great part about this talk is definitely introductory, but as I was rebuilding, as I was building a slide, I was re-remembering things I hadn't seen in a while. So why do they matter? Well, one, they do address complexity, although a lot of times they add complexity. You'll actually hear me say that a lot of times when I talk about drawbacks. Well, this has a tendency to add complexity. It's usually because people go overboard with things. But they do encourage that best practice. They encourage standardization. All right. The fact that I'm saying, okay, we're going to do the builder pattern, right? I am going to talk about what the builder pattern is, but we're going to do the builder pattern. Well, then I know, when I tell a dev team, okay, this architecture is using the builder pattern. Well, they've done the builder pattern before. They know, okay, well that means, we're going to define a builder, and it's going to have its, it's going to have its composite objects and so forth, right? It makes it more standardized. By using patterns, we help with readability and maintainability, right? And these are two of my big pet peeves, right? When I do code reviews, that's one of the first things I look for, right? Is how easy can you read that code, and how well can we maintain it, all right? Because as a software leader, maintainability is one of the most important things. And that's usually what suffers, because we usually get in a hurry, and so we have to write really quick code, and so we can't write as maintainable. And then the companies wonder, a year later, well, why is it so expensive to update this application? Because it's really hard to read it, right? But using design patterns will help with that. And then, because it's a standardized pattern type thing, it helps facilitate communication, right, and collaboration. Because again, once when I say, okay, well, we're going to do this, we're going to do that, right? When I meet with my team of architects, we talk about patterns and what we're going to use for things, and right away we know, okay, well that's what he means by that. So design patterns, they've been around for a long time, all right? Really, probably since the very early days, so probably 50s, 60s, we probably really started seeing design patterns, but really got popular with this book. So elements of reusable object-oriented software, right? So these four guys they're commonly referred to as the Gang of Four, all right? Because this book really, it's not that they wrote about anything new, but they put it in a collection and they classified things, right? And that's you had one place where you could find all those things. And again, this was published in 94, right? So the internet basically wasn't really much at that point. That would be before the World Wide Web, right? So, there was an internet, but, at that point, it really was just text pages, right? That, and you were reading HTML. But yeah, so they defined it. And again, one of the big things that they did was not just have a book of collection of these patterns, but also they categorized them, right? And they created these types, right? So they said, okay, well, and they defined 3 different categories. So you're creational, right? So patterns that help you create objects, right? You're structural, so things that provide structure, and then finally behavior, all right? And again, I'm gonna go into these more details. So let's talk about what we mean with creational design patterns, right? Again, these focus on object creation and providing flexibility and reusability as you're building these things. That's one of the big key tenets, right? Is making things flexible, making it easy to extend your patterns. And so what I've done, I will say, for each of the categories, I picked 2 patterns, right? It's a little bit hard to say what is the most important pattern. I hear that all the time. Oh, well, what's the most important pattern? Or what's your favorite pattern? Well, it really depends on what you're doing, right? But I did pick 2 of each that are probably the more influential, probably the more common ones, sometimes the more misunderstood ones, right? And the first one we're going to look at is the builder pattern, right? So basically the idea of separating complex objects from its representation, right? So let's look at it in pictures. I like pictures. It's funny, we're in the middle of reorganizing our office space, and I told the IT director, I'm like, I don't care what else you give me, you've got to give me a whiteboard. I got to draw my pictures throughout the day, right? So what are we talking about with builder pattern? Well, it starts off with your builder interface, right? So defining what we need. It defines the steps involved in constructing the product, right? So whatever that means on that. And then you have your concrete builder that implements that interface, all right? And I would say, don't worry so much about, you'll see this terms like concrete and composite. don't worry so much about the terms. Just think about the ideas that we're talking about here, right? But it implements an interface, and it provides the actual implementation of those, right? And one of the great parts is with the builder pattern, I can have the interface, but I can have multiple types of products going against the interface to build different types of products, right? So again, we build engines, right? But we also build transmissions, and we also build transfer cases and a couple other things, right? Well, we can use the builder pattern in applications to say, okay, well, this is a builder for an engine, a gas engine, but it has these common patterns that we use, right? And then finally, you have your product, right? So what is actually the end product? What are we going to build, right? So this would be, in the normal, one of the normal patterns we talk about is the animal and then the cat and dog. So this, you would have your animal builder, and then it could build like a cat or a dog or what have you, right? That's what the product would be. And then finally, you have your client, right? And so your client will make a call out to the builder, and we'll get the object that it needs. And then, like I was already talking about, again, one of the benefits here is you can have multiple builders to build different types of products, using the same interface. So again, you can start to see some of these benefits, right? It's because it's using the same interface. I know whether I'm creating a cat or I'm creating a dog, I know that I need to give it at least some standard values that we need to know, right? And then there is an optional piece, so the director. And the idea here, so if you think about this, before we get the director, right? Here, the client needs to know about how to use the different concrete builders, right? So because while they might be similar, they have an interface, but they probably also have some extra fields, or they have some extra rules with it, right? That's where this director comes into place. Because now, instead of the client going directly to the builders, it goes to that director, who then has that additional knowledge of how to grab these resources. All right, so how does this look like in code, right? And I will say, everything I'm talking about does not matter what language you're using, all right? Any computer language you're using, all these patterns can be used. Now, one, this is LouDotNet, but two, I'm a C# guy, so it's going to be in C#, right? But it doesn't matter the language. So here we have our product, right? So we're going to build a pizza, and again, slightly different order than what I just talked about, but it's going to make sense how we do it. So I've got my pizza, cross sauce. It's got its toppings, right? So then we're going to have our interface, right? Here's our builder interface, and again, build crust, build sauce, build topping, get pizza, right? Again, honestly, that's an over-exaggeration. You probably would not, Papa John's probably does not have a class builder like this, right? I mean, because that, it wouldn't necessarily make sense that way. But, for demo purposes, this works. And then here we've got, everyone's favorite, the Hawaiian pizza builder, right? So again, but the point is I've got my concrete builder, right? It knows that it wants to build a Hawaiian pizza. So it knows that it needs that classic marinara. It needs the ham and pineapple toppings, right? It has all this knowledge to do this, right? And using that interface, right? And then, you can have your director being here. We've got the waiter class, right? So you order your pizza. And again, the director takes your order and will build the pizza. And then finally, you've got your client. So your client says, okay, give me I want a new Hawaiian pizza. Have the waiter construct the pizza based upon that I provided it. I want a Hawaiian pizza, and then it will build it, right? So pretty simple, when we really boil down to it. All right, so how's the builder pattern used? Well, let's think of some things in .NET, right? Number one is a string builder. And it's right in the name, right? So it's pretty obvious. This is one of the things it's doing. The idea that we keep on building on to a string builder. Now, of course, string builder is a really important class to understand. If you're new to C#, definitely learn about the string builder. Don't concatenate your strings. But that's an example. Your fluid interfaces, right? So here that dot users, dot where, dot order, dot select, right? That's a builder, right? Because every time I'm doing all those things, it's actually calling out to a builder. In any unit, the assert dot that, right? Or and so forth, right? Here, you've got is equal to, ignore case and starts with. That's that's an example of a builder pattern. You're going to see ASP.NET in a lot of these examples, right? Because ASP.NET uses a lot of different patterns. Here, how we configure the options, right? The final one I've got, your JSON serializer options, right? Again, the fact that I've got an options class and I'm adding things into it to build for me. All right, so some benefits of it. Well, first off, separation concerns, all right? Because now that client does not need to worry about how the product gets built. All they need to know is, hey, I wanted that Hawaiian pizza. Arissa's hungry. She wants that Hawaiian pizza right now. So, she doesn't have to worry about how that gets built. She'll probably throw it right away, but, okay. Encapsulation, right? Again, the whole idea, I've encapsulated that code away, right? I don't have to, I can, which also means I can reuse it, right? Because it's encapsulated. Apparently my animations aren't right. That's all right. Reusability, same thing I was just talking about, right? The idea, hey, we reuse this over and over. We don't have to do the same thing. Look at those .NET options, right? Those perfect examples of how things get reused. There we go. Here's where I really like to start using them is, when you're building really complex objects, right? Things that have a lot of logic, maybe a lot of conditionals, right? One, we probably don't want our client applications to know how things got built, right? All they need to know is they needed these objects, right? But two, again, it's a way to kind of put that code away, have it in a central location, especially when we're building these complex objects. And then, no, it's not finally. Animations are all screwed up. But again, your control over the construction process, especially if you're in a distributed system, if you're doing microservices, I don't want that client to understand how it gets built. All they need to know is, they got the Hawaiian pizza. All right, and then finally, immutability, right? Because the fact that another class is creating the objects for you, right away I can help enforce immutability because I don't have a way to create these objects, and I probably don't have a way to edit them, right? Because at this point we can make them read only and so forth. So it really helps with that. Now, with that being said, some great options, some great benefits. There are withdrawals. There are. Why does this say times? Okay. Like I said, I have not had a chance to walk through my slides. Really talking about drawbacks. So increase complexity, right? I spread out the code, right? I now have to go look at several different places, right? And I will say, this is something you'll hear a lot with different patterns, right? It's, because once I've used a pattern, I probably have built code, quote unquote, better, but it also means now I have to go to more places, right? It has a tendency to generate a lot of boilerplate code. Because now, like I say, I'm just rebuilding things. Think about like the ASP.NET options. What's great that I have this builder pattern to do it, but you know what it means is every time I start a new ASP project, that's the very first thing I do is write this boilerplate code, right? Same type of situation. You have the potential for overhead, and this is just because, again, you're depending on another class to build your stuff, right? So you have that potential for overhead. I definitely have a high potential for duplication of code because you might have, that's not helping. That helps. Think about like the pizza, right? Well, the Supreme Pizza, and I don't know, you might have like two kind of pizzas that are really close to each other, right? And so you're doing a lot of the duplication of the same type of code, and and that's what the pattern dictates, right? But you have that a lot. You have this. You can have limited hard to apply it in multiple places. Easy for everyone else to say, apparently not for me. But because it requires multiple steps to construct, it might not be applicable in multiple places. Is basically what we're getting there. And then finally, you have this potential for inconsistency, right? Because different builder patterns are doing it differently, and maybe you're going all over the place. So it's you're not being as consistent. So that is supposed to say drawbacks, not times when not to use. But things you have to definitely consider as you're thinking about this pattern. Times to use, right? So one, I have a really complex object I need to create. Things that have a lot of steps, right? Get the code away, right? And put it away in another place. Makes a lot of sense there. I have a lot of variability, right? Pizza is a perfect example, right? If you look, you look at the different types of pizza. Well, there's a lot of similarity, but there's also a lot of variability, right? What options are being there. And that's where the builder pattern works well. Again, that immutability and thread safety, right? Thread safety is not something we need to worry about as much as we used to. But if you start building high-performing applications, and I don't mean what most customers think are high-performing, I really mean true high-performing applications. Thread safety becomes important, right? And that's this will help with that. There's the whole idea of the telescoping constructor anti-pattern, right? And this will help with that. So think about where you've got multiple constructors, right? So think about let's just say you had a pizza class, right? And in your constructor you had, okay, well, pass me the toppings. Okay, pass me the toppings and the crust. Oh, okay, pass me the toppings and all these different constructors. All right, that's what a telescoping constructor is. Well, with the builder pattern, we get away from that, right? Because now you have different builders to handle that instead. You're creating your composite objects. Another one is testing. All right, builder pattern is great for testing because guess what? I need to do a lot in testing. I need to build objects. Right. I can put that in a separate logic, have it tested separately, and then be able to test my other logic and not worry about the builder, right? Normally when we talk about unit testing, one of the things we always tell you, but don't worry about testing like the entity framework code, right? You don't need to worry about testing that. It's been well tested. Same idea here, right? I could test that builder logic separately and get that well tested. And then my client applications, again, they can skip that part. They can just go down to the next part of things. So it's a great time to use, but there are some times not to use this. If your objects are really simple, you're just going to add complexity to your code, right? So it doesn't make sense there. If your configuration is static, right? Maybe you have 3 or 4 different objects, but they never really change, right? There's not much, variability in there. You're going to be wasting some time. Which I just talked about, limited variability, right? Again, it's not a whole lot of differences between your different types. Okay, so performance sensing applications. I already talked about this, right? Again, most of us are not actually building performance sensitive applications. Examples of performance sensitive applications. I did once work on one, actually twice in my career, right? First time, I was working for a company called Store Value Systems, just down the street. They build systems to manage gift card processing and a bunch of other things, but that was the main business, especially when I was there. We had SLA contracted times, and again, this was 20 years ago, of what was it? Less than 4 milliseconds, I think it was. All right. That was crazy talk 20 years ago, right? There's where we're talking about a performance sensitive application, right? I had to do everything possible to not slow things down. The other time I did it, again, a long time ago, I actually worked for a chemical robotics company. And everything, again, it was timed by milliseconds, right? Shake this vial for 30 milliseconds. Well, obviously, it couldn't take me 20 milliseconds to make that call, because I would run out of time. So those are examples where, you got to worry about this. So point being is most applications don't really need to worry about that constraint. But, again, something to think about. Another time is, of course, I think this is normal, when we have a tight deadline, right? Because it's going to take more time to build a builder, right? Because again, you have more code you have to write and so forth. And then finally, when you have highly coupled objects, because part of the idea of the builder pattern is to decouple things, right? Well, if it's really highly coupled, then you're going to have problems. Now, I will say this: if you have highly coupled code, you probably should be looking to see why you have highly coupled code and try to get rid of that. All right, I mean, that's, again, one of my big pet peeves. So good times to use, good times not to use. All right, so that's the builder pattern. Any questions on the builder pattern before I go on? Awesome. Sure enough, I mean, interrupt me at any point. Okay. So next pattern, right? Again, another creational pattern, and this is the factory pattern. Now, I'll tell you what, the factory pattern, I think the first time I learned about it was probably 98, 99, sounds about the right time that I found out about the factory pattern. And like, I started applying to everything I built. I'm like, this pattern is so awesome. I just started using it everywhere, right? And again, that's part of the problem, right? We learn about these patterns and we say we're going to use them everywhere. And the factory pattern is really great, but it's not great for everything, right? So what are we talking about? The idea, it's very similar to builder pattern, right? Because they're all about building objects. But here you've got a separate factory, right? So it's a little bit more non-discrete, right? The builder is a little bit more closely tied to what's building. Factory is a little bit less tied, right? So, well, this works. If we look at the code here, we got our ammo example, right? So I've got my abstract product. It's going to, here's what we're going to end up building, right? So animal, we have that method of a speak, right? So then you have your concrete product. So what are you actually going to build here? So here you can see I've got my dog class. It inherits the animal, right? And so it'll override the speak with the line of code that we're doing here, right? And then finally you have your concrete factory. So this is what your client code will call, all right? Excuse me. Very simple logic right in here. Give me create an animal. Here's what type of animal I want, and then based upon that type. Now, grant you, this is very simple code. Factory patterns do not have to be this simple, all right? But one, I'm trying to show it on a screen, and two, I'm trying to show it in a presentation. So it is a little more simpler. And then finally, you got your client code, right? So dog, equals animal factory, create animal, right? And then I can call it to speak, right? And what does it say? It says dog says bow wow or whatever I put in there. But some really pretty simple code in here. So examples of it in use. Well, again, another obvious one. Actually, I think this is the way how I found out about the builder pattern is or similar is one is your DB provider factory. Now, most everyone probably has never touched the DB provider factory because most of us use any framework nowadays. But any framework actually uses this. This is a way how to build data connections, right? And one of the great parts about this one, I have my Git factory and I feed it a name, right? So this one's getting a SQL client, but it could be an Oracle client, it could be a Cosmos client or what have you. Another example is your system.io stream, right? So think of this idea where I want to get my stream, and so I just say, hey, give me give me a file stream, right? Or give me a memory stream, or give me this type of stream, right? The final one I've got in here is the system text encoding, right? So again, get my encoding, right? So that is a builder pattern. All right, so benefits of the builder pattern. Well, again, encapsulating the code, right? Because that logic that takes to build your objects, you've encapsulated it off. You're not having to worry about it in your clients. It helps provide loose coupling, right? This is one of the things that factory does a little bit better than the builder pattern, but it definitely helps with that coupling, loosening the coupling. Because again, I've got a separate object that is handling all that object, that type of stuff. It does enhance your code maintainability because again, I know a single area. Helps with scalability, flexibility because I can be more scalable. It improves testability because again, the logic is in one place, right? So I don't have to worry about how I built the object because I can get that tested separately. And then finally, as far as benefits, consistency in object creation, right? And I think this makes sense, right? The idea that every time I'm creating these type, that cat or that dog, or whatever kind of animal we're creating, right? It's consistent, right? We know it's always going to be the same way. When we add a gerbil in there, right? Well, it's still the same thing. I'm not exactly sure what a gerbil says, so I'm not sure what the voice, the speak commands could do. But you get my point. So some really great benefits. Again, this is a simple pattern, really what it boils down to, but it's still powerful. Some drawbacks. Again, you will hear me say this with almost every one of these: increased complexity. Right? I have more code. I have to look at more places. Right? I can't just follow one class of code. I now have to go off to somewhere else. Right? Again, that performance overhead because I'm calling another class. I'm probably have that in another class library, so I'm probably bringing in objects. Again, mostly don't have to worry about that too much, but things to consider. What did I tell you at the beginning of my story about the factory pattern? I loved it so much, so I put it in everywhere, right? That happens a lot with a lot of these patterns, right? But the factory pattern seems to be really common with this kind of problem, where all of a sudden, you just use it everywhere, right? So you have to watch out for that. You have a tendency to get hidden dependencies. And what I really mean by this is because, again, say I have my client code, right? And I have a class library that's implementing the factory library or pattern. I have no idea what, as a client, I have no idea what it's really doing, which means I don't know what dependencies are hidden in there, right? And here's why this becomes important. Think about security, right? I have no idea if that's all of a sudden has a dependency on a package that is no longer secure, right? It has a vulnerability, right? Luckily, like Visual Studio and stuff are actually really good at detecting that, which is so funny because someone's having fun. It's so funny because just the other day, I was reviewing a product I haven't looked at before, and I got it in Visual Studio because I'm doing a code review, and I'm like, oh, you have vulnerabilities in this. You need to fix those. What do you mean we have vulnerabilities? I'm like, Visual Studio's telling you right here. It's like, and they're like, well, that's not our package. That's a package that I don't care. Still got to fix it, right? That's kind of what we're talking about here. Definitely things to have to consider. So times use. Well, number one, database connection management. All right. Again, most applications don't worry about this anymore. But think about if you're building a SaaS application, you're working with software as a service company, and think about like you're building a product or not even in SaaS, but where your product works on SQL Server and works in Oracle and works on Sybase. Sybase still around. But you're working. Here's where the factory pattern works really well, right? Because again, I can say, okay, well, customer A, they're on Oracle. They're rich bag money guy because they can afford Oracle. So I see a couple of people who've worked with Oracle before. So the factory pattern builds it that way and so forth, right? I forgot I had an example, right? So again, I can have my Git factory here. Your logging frameworks, right? Here's another perfect example where you can use this. So again, create my crate logger, right? This is very common to use this in logging patterns. So with that being said, please don't build your own logging pattern. Use something like Serialog because it's already built, right? It's again, you don't have anything when it comes to logging, it's already figured out. Parsing different file formats, right? So in here we've got an example of a document handler. Create my different documents. So think of like where maybe you have an application and you can either spit out an HTML document, spit out a PDF document, spit out a Word document, right? Again, the factory pattern works well there because you can use you can have the pattern built that way for you. All right, so some good ways to use it. Some other ways, just to keep it going, payment processing, shape creation, right? These are some other examples. Sometimes not to use it. Again, simple object creation, just like we were talking about with the factory or the builder pattern, right? If it's really simple, why are you going to go through the trouble of having a whole other class and actually multiple classes? Your interface and your all that kind of stuff. Again, that performance critical applications, right? And again, I'll say this, because again, I'm going to say performance critical applications multiple times through here. Here's the thing: when you do performance critical applications, you end up doing a lot of things that are technically anti-patterns, but it's because you're building the absolute fastest software. I will say one story. I forgot what the name of the package, but like a month ago or 2 months ago, there's a package that a really popular package, especially in the Linux world, that got compromised, right? And it boiled down to, I mean, basically, this guy, it was an open source project, and this guy actually became really good friends with the open source project and actually ended up taking over the project and then slowly introduce some vulnerabilities so that he could steal data, right? The way how it was found was actually a Microsoft guy who was working on a performance critical application. Notice the process was taking like 3 milliseconds longer than it should be. And so he was digging into this to figure out what was happening. And basically found that this thing was sending out, packets of data, and that's why it was slowing it down. That's where critical, applications come up, right? When you need to do that kind of stuff. Some other things, you hardly make changes to to the way how objects get created. Again, you're going to add complexity for not much bang. That's the reason why it's not so great. Your configurations are static, right? So think about like that logging pattern, right? Where, like I say, most loggers use the factory pattern of sorts, at least. And the reason is because, we'll have different types of configuration, right? We, in a web application, I probably want a logger to go to the screen, but also, some type of logging to go to screen, some type of logging to go to a central logging, and maybe somewhere else to send an alert if it's serious enough, right? And maybe in another application, I needed to go, these other places, right? There's where it's not static, right? You have a lot of changes. But if it was always the same, you're kind of losing some of the benefits, and you're adding a lot of more work to get these things done. So, in a nutshell, that is that pattern. I'm noticing the time. So, all right. So let's move on to the structural design patterns. We're not doing horrible in time, but it's going, but I'm also only a third of the way through. We're gonna work. So all right, structural design patterns. So these define your structure of your application. So you've built it, but now how we deal with the structure? How do we manipulate these type of things? So that's where these kind of patterns come about. And your first one is your decorate pattern. This is great because here I could take an existing type of class and basically I can add, responsibility to it. I can add methodologies to it, right? I can decorate the class. That's how the name comes up to be. So what does this look like? Well, again, let's draw some pictures, right? So here you've got your code component, right? Here's your base object, right? I want to, that's great. It does this great thing, but I need more functionality out of this, right? Well, so I have my concrete implementation that implements that, but I add this decorator, right? That basically allows me to do some additional stuff. And decorator might have multiple compositions that allows it all to get built. So how does this look? Well, so here I've got my interface. I have my iCar, right? iCar. Yeah, I did say that right. Didn't sound right. With the assemble method, right? So this is this represents this core component. The next, I've got the concrete implementation. So here is this is my implementation of the interface, right? So I've got my basic car, I've got my assemble. So here it's just basic cars assemble, right? So very simple for But then I can add my decorator, right? And here in my car decorator, I take in the car, and I'm basically What am I doing here? Oh, because you see in the next one, that's why. So you take that. So then here's where the great part is. Then I have my compositions, all right? So now I have my sports car, right? And I have my luxury car. It takes in that car decorator, but allows me to now add properties into this, and to make this a lot easier to do. So now when I get to the client, and this is very similar to like the builder patterns we were just talking about, but here's with code that's already existing, right? So here now, like I say, I can, have my different types of cars and get whatever I want. Down at the bottom, you can see where, I've actually have combined them together, right? So I'm creating a luxury sports car, right? Just by combining these things together. I will say, this is great. We could make this a little bit faster. Here we use concrete types instead, right? So instead of having it multiple, bringing in, this class and then that class, right? So it has nothing really to do with the pattern, but, actually Visual Studio recommended it to me, and I'm like, well, that is a good thing to point out. All right, so how does this get used if we look in .NET? Your stream classes, right? So, because again, it's taking, stream class, the way how it works in general, right? There's a stream class, but then you have your file stream and you have your memory stream, and it's decorating on top of those. So it's taking that base thing and adds the things that, make sense there. So like the file class, decorates it with a read file and a write file, right? The memory class, has I can't remember off the top of my head, but I know things like dump memory and such, right? Your ASP.NET Core middleware, right? I mean, it uses a lot of decorator, right? The idea of how do we, add things into this. And then your attribute decorators. I just noticed on the screen that doesn't come out very well. But some other things, logging frameworks and encryption and compression libraries. These use decorators a lot. All right. So benefits. Number one, I get enhanced flexibility, right? And the idea of I have that base object, right? But now I can add to it, right? So a very common way of doing a decorator pattern is what's called extension methods. And the idea of, hey, I want to extend what I'm, a method that already exists, right? Same idea, right? I can add to that flexibility. I can add things to this. The pattern, it promotes the adherence to the open close principle, which states that classes should be open for extension but closed for modification, right? So if you ever heard of solid, right? This is one of the parts of solid, right? The whole idea, allow it to, I can make, I can't change it itself, but I can extend it. I can make it easier, right? So the decorator pattern happens with that. Also helps with the single responsibility principle, because again, I can have that single responsibility, but then when I need to add more responsibilities, I can add a decorator for that purpose. And then it helps with modular reusable code. I think that makes sense. And then, fine grain control, right? Because again, I can narrow it down, but then, I need to add this specific type of method in here, right? We can do that. Think about the stream IO, right? Or the IO stream, because, it has fine control. I decorated with the file methods, so it adds only the things that a file would need, right? And then finally, certainly transparent to clients. Most of the time, clients have no client, and by this I mean a client application, right? Has no idea that that class was decorated and had extra things. It just knows it's there, right? Again, extension methods are perfect for that, right? Once I add an extension method, when I have a client class that's using that, as far as it knows, that method's there. But if I didn't have an extension method, it's not, right? So some great benefits, some drawbacks, complexity, right? Again, this is something you hear a lot, right? That performance overhead, right? Again, you're gonna hear that a lot. Maintainability, right? Because now here's the problem with the decorator pattern. I now can't look in one place for that code. So if I added it to one area, well, I only have to go to one place. Well, now I might have to go to a couple of different places to look to see, well, this has got this decorator, neck decorator, and that other decorator. So it kind of adds to the maintainability. I got to look at multiple places, which potential for object proliferation. And then, finally, you have issues with the dependency ordering, right? The whole idea of how do they rely on each other, right? I mean, that can cause some issues. All right, good times to use. You want to add functionality dynamically. Again, I keep on going back to the extension methods. That was the whole idea of adding extensions. Is my class, I need this I need this additional functionality, so I can add that in there. Again, extending functionality without subclassing, right? Because subclassing is a little bit more expensive when it talks about performance. This helps with that. Again, the open-close principle compliance, we talked about that in the benefits. When I'm going to combine multiple responsibilities. And then finally, when I need to dynamically add features. Sometimes not to use it, and I'm purposely speeding up a little bit. If you just need to add simple functionality, right? I will say, I ended this in here, after some research, and I don't know if I completely agree with this one, because I do this a lot just for, I will extend methods just to add simple things, because if I'm going to do them multiple times, that makes sense, right? You have deeply nested chains, right? Because again, talk about hard times to maintain this, right? You're going to have a harder time. Performance critical, we'll hear that over and over. When you have tightly coupled decorators, again, my whole thing, you shouldn't tightly couple your code anyways. And then you have complex ordering dependencies, right? So I would say the bad times to use, again, a lot of those times, you probably, other than performance, that's a whole different problem. But a lot of these, you've got other issues a lot of times anyways. All right. So adapter pattern. So here, this acts as a bridge between two incompatible patterns, right? So, the idea of, I got these, I need to use two different types of things. They're similar, but they're not exactly the same, right? That's kind of what we're talking about here. So, some key concepts, right? So you've got your target. This is the interface that the client expects. You've got your adaptee, right? So this is, your existing class with an interface that doesn't match what you need, all right? And then finally you have your adapter, right? So think of, you've got a class that produces Word documents, but you need PDF documents, all right? Well, you can add that adapter that can adapt that to generate what you need, right? That's kind of what we're talking about here. There's two different types. One which you'll never use. The first, and that is the class adapter, right? So here, inherits from both the target and the adapter. And the reason why none of us will ever use this is because you have to have multiple inheritance, which we do not have in C# or in .NET. And even though Java says they do it, they don't really have multiple inheritance. But if you're doing like C++ or straight C, then you'll start using this kind of stuff. But then you have your object adapter, and that's what we can do in C#. All right. All right. So here's some code of looking at this. So here we've got a media player. So it's got the play command, right? Takes in an audio type, takes in a file name, right? So that's my target interface. That's what the client code will actually go against. And then I've got my adaptee, right? Again, very simple, right? But play MP3, so it's just going to print out MP3, right? Play WAV file, right? So here's a way to allow a media application to be able to play different types of things. And then you have your adapter, which again just goes through the logic. Says, okay, what do I need? Okay, we'll call that adaptee that implements that type of thing. And so when we go into our client code, right, I can say, player.play MP3 Thunderstruck, right? And it knows, okay, well, we're going to rock out AC/DC, with in an MP3 mode. We have our wave, back in black, and our unsupported Hell's Highway. Sure enough, that is not an AC/DC song. I literally had I asked ChatGPT to come up with some fake AC/DC songs to come up with my unsupported. But point being, you get the idea, right? This makes it really easy to use the client. Again, doesn't need to know how it works. All he needs to know is, I have this file, I need to play it. A couple things that gets used in .NET. One is your stream adapters, right? You'll see the file streams and everything get used a lot here, right? But they use this. Another example is your I collections in your I list, right? Because think about it, like I can do an array list into a list, right? So it's using adapters in there a lot. Okay, so some benefits. Number one is that interface compatibility, right? I can have that one interface that just knows, okay, well, it's going to work no matter what, because whether I need a WAV file or MP3 file, or I need a Word file or a PDF file or what have you, right? Definitely builds reusability, because now I can reuse that code. Probably more important is I can reuse code that was existing before, right? That's one of the great parts here, which gives me flexibility, right? Because I don't have to rewrite that code. I have the flexibility of using what we had before. And then really helps with ease of refactoring. So think about, so like in the situation I'm at, I'm at a company, our company is 80 some odd years old. They've been building programs for a long, long time. So we've got a lot of legacy code that we're trying to rewrite. Well, here's one of the ways we could do this. We can add adapters in there, as we write the new stuff, but still have old stuff, going into it. It's a great way to get around those kind of things. Some drawbacks, again, common thing, increased complexity. I've got more code out there, right? Plus now I need to know, okay, we have to call this adapter, right? So we have to think of it that way. Performance overhead, maintenance burden, right? Well, now for every different type of adaptation that I need to write more code, right? So, that's more code that has to be maintained. It's more code that when changes happen, I have to, work on those changes, So when Microsoft decides to rewrite the Word format, which they have done, they're not going to do that again, but, they have done that. Now all of a sudden I got to go back and change all that code because now it's, it's different, right? Or maybe I have to add another adapter that handle that. So again, I talk a lot about, you should watch out for coupling your code, right? What I mean by coupling your code is where, one piece of code really knows how the other piece of code works, right? That's kind of what we're talking about here. And an adapter pattern, I have to know, well, it knows that it has MP3s, right? Well, and it knows that it can do waves and so forth. We've kind of tightly coupled that. So those are some of the, benefits and drawbacks. Times used. Again, I was just talking about the example, legacy systems, right? You're building your new applications, but you still have legacy applications. They're writing code and writing documents out there. You can use this. Using third-party libraries, right? You want to do it your way, right? And you don't want to do it another way. Or prime example. So one of the things we built, we're engine remanufacturing. So we deal with VIN numbers, right? Well, so we don't have all the information on all the VINs. We go out to other vendors. Well, guess what? We have a couple different vendors. They don't all provide it the same way, right? So we use the adapter pattern to adapt that, as it comes back in. So my applications, they go to one central place, say, hey, I need it from this place, but I want it the way how I always expect it, right? Facilitating API changes, so you make changes, you can add that adapter pattern there. And by API, I don't just necessarily mean like a REST call. I mean even like your code, the API of your code, and then bridging different technologies, right? And then finally, adapting vendor-specific implementations, right? All very similar type of things, but the idea of I need to go between a bunch of different things. Times to avoid, overcomplicating your simple interfaces, right? Again, this is common what we said with all these things, right? But if it's very simple, maybe you want to make it more simpler in here. You have a temporary fix, right? This is only going to be around for a year. It's only going to be around for 6 months. Well, maybe not going all the trouble of building an adapter pattern, right? Maybe just put the code in there. Times of avoid is when you're avoiding proper refactoring, right? I'm doing this just because I know I don't have to refactor that nasty code that we don't ever want to touch, because Bob is the only one who knows how that actually works. Hopefully there's no Bob in here. But that's this is not a time to use this, right? And then the typical performance critical applications, right? All right. So we've gone through two of the categories, one more to go. Yeah, we're doing fine. I know I can't do this in an hour-long presentation slot, though. That's for sure. Not the way how it's written. Observer pattern, right? Oh, so here the idea. So we're talking. I'm sorry, I went too fast. The behavior pattern. So these are defining behaviors that happen, right, within your class. And a prime example is like your observer class or pattern. This is where I want to observe what happens, and I want to take actions, right? For those who know me, I do a lot of talking about event-driven architecture. Observer is a big part of event-driven architecture. The idea, I'm watching for things to happen and see what it does. So how does this look like? Well, you've got your subject, right? So, what are you watching for? What are you looking to change? And you have your observer, right, that is looking for those changes. And then finally, you have your concrete subject that concretes that, your concrete observers, right? Honestly, it's even simpler in this chart. It's just that, hey, I have something that's watching for something to happen on this type of object. That's really what it boils down to. How does this look like in code? Here's your subject. You have your interface, so attach, detach, notify. I have my observer, right? So, observer a lot of times will have an update method, right? So to let it know that it updates. And here are my subjects. So, I've got my observers, right? Because a lot of times you'll have more than one observer. So who wants to know when this subject changes? And then I attach those observers, I detach them, and then finally my notify, right? So hey, we made a change, so call that notify, and this is a very simplistic way of doing this, right? But just go through each one of those and run this. I will say if you get to a big enough system, doing a simple for each is probably not going to work very well, because a lot of times, you might get another notification while you're still sending out to some of the clients. So that could be a problem. And then you have your concrete observers, right? The idea, so I care about this. I'm observing this to happen. So, I implement the iObserver, and so I get notified, I get an update when that happens, right? I get notified. And then finally, we have our client. So here, it's going to create a concrete subject. It's going to, then create my observers, and you can see I'm sending notifies, and then, so those observers do whatever they need to do. Some examples of these working. One of the more obvious ones is your event handling in Windows Forms, right? Or it's just now Win Forms, but same difference. So I have my button click, right? So that works, right? A perfect example. Your I notify property change, right? And that's all about the observer pattern, right? The idea of, hey, tell me, and again, unless you're doing Windows client code, you've probably never seen this, even though you don't have to be using Windows client, but that's the place you normally see this. But also, in the reactive extensions, you have your observables, right? That's another prime example of this. One more, and I don't have code on this, but your middleware, right? Because a lot of your middleware, that's exactly what it's doing. It's waiting for something to happen, and then your middleware says, okay, do this when that happens, right? When I get, so routing is one of the middlewares, right? So when I get foo/bar, right? That's I get a notification. I'm observing that address coming in. All right, so some benefits. Big thing about is loose coupling, right? Because I'm no longer reading exactly the subject that I'm reading. I'm waiting for the subject to basically tell me that something happened, right? And so I'm loosening a couple. I'm loosening the connections to everything. It promotes modular design, probably pretty obvious. Again, event-driven architecture, which in my life that means everything, right? I do a lot of talking about event-driven architecture, so it's obviously it's important to me, but it definitely is a benefit here because we can promote that. And then support for broadcast communication, right? The idea that I need a lot of things to know when this happens, right? Well, there you go. Think about like an alert system, right? Well, I need to alert all these different people, when this something happens. Well, that's what the observer pattern is about. And then finally, encapsulation, right? I can move that code off and have it in a separate place and encapsulate that. And actually, finally, was the flexibility. So drawbacks. Guess what the first one is? Performance overhead, right? Here's the funny thing about performance overhead here. This is a little more true. And this isn't necessarily just that, really high, I care about every millisecond, right? So the one thing to think about this is I'm now, as a subject, something happens to me, and I start sending out notifications. Well, depending on how those notifications happen, that could take time, right? And I talked about like that for each could be a bad thing because maybe it's, you get your next one and then you're still sending out other objects. So here, performance gets a little bit more important. You do have to think about this. Now, with that being said, like I say, I do a lot of presentations about event-driven architecture, and I build whole systems on event-driven architecture. So obviously, and those systems are very performant, right? So you can handle this, but you have to think about that. You have memory management concerns, especially for that, the thing that's sending out all those notifications, right? It has a tendency to use up a lot of memory because the more observers it gets added to its collection, that's in its memory, right? It has to know all about that. It definitely adds complexity, no question about it, right? I now have more code. I have code that doesn't directly connect to each other, right? Again, that big benefit of loose coupling is also a drawback, right? Because now, I don't necessarily know who all is connected to this, which to me is also a benefit. You have that potential for circular dependencies because, I can send out a notification and then maybe that notification is supposed to trigger off another event that sends off another event. You can easily get into that. And then ordering notifications. And again, this kind of depends on exactly what type of system you're building. But like in event-driven architecture, we always tell you, I cannot necessarily guarantee the order that you will receive messages, right? And it's true here. And then finally, it is more difficult to debug, right? Because again, I can't just have a breakpoint, in F11 through my code, and it's going to hit that observer because now I have to have a breakpoint over there also, right? Because it's a different piece of code. So again, benefits, drawbacks, things you want to consider as you think about this. As far as times to use, number one, user interface updates. Again, like I say, so sure enough, I grew up on this kind of pattern because number one, I've been doing .NET since it was originally in beta, and before that, I was doing VB since it was VB1, and before that, I was doing, I've been in Microsoft for a long, long time, and so I built a lot of crappy user interfaces, but they're all built. Microsoft was built on this whole idea of that's why it was so popular. It was so easy because it was all event driven. It was using an observer pattern. So perfect example using that. The obvious, I want to handle events, right? I have another talk that actually I talk about how patterns can have problems. And I actually talk about the observer pattern and, talk about event handling, right? And the reason why I talk about that is because, this is a great time to use it because, where was I going with that comment? I can't remember. But anyway, event handling. Your publish subscribe systems, because that's what you're building here. Your MVC and MVVM architectures, right? If you think about it, some of that is already using this type of pattern, but these are great for that because again, they're kind of implementing similar things. When you need to monitor systems, and then your distributed systems, right? A lot of times when we use event-driven architectures to help with distribute these systems, and the observer pattern becomes really important. And then finally, your logging auditing, right? Those are some great examples to use this. Sometimes not to, if it's a very simple event handling, right? And by what do I mean? Well, I guess one of the prime examples is I know there's only ever going to be these two things I need to know this happened, No one else is ever going to need to know this. All right. Well, then going through all the trouble, the observer pattern and sending out messages and all that kind of stuff, that might be too much. All right. So that's the time not to use this. If for some reason you need tight coupling, right? There can be reasons for that, but it can be hard for that. Your performance critical systems, again, every single one of these has that. Your static configurations, again, your configuration doesn't change very much. You're not going to get much benefit here. And by this, what I mean is that the observers are very similar to what they're doing. There's not a variation of what they're doing. Well, then you probably should consolidate those observers. And then finally, if you have complex dependency management, right? If you got a lot of dependencies going out there, that's actually not finally, but that's going to cause a problem. And the finally is asynchronous communication. Because like I said, again, you're not guaranteed when you're going to get that message, right? You're going to get it, but you don't know when, right? And so if I need that get taken on, I didn't realize I have one more. The flexible configuration. All right. One more pattern. Yeah, we're not doing too bad. Strategy. So the idea of strategy. So this is the idea where it defines a family algorithm, and basically you say, we're drawing a blank what I want to say here. Okay, yeah. Here's the idea where I want to, I'm going to build a strategy that says, well, if I'm doing this, then we're going to do it this way. But if I'm going to do this other type of object, then we're going to do it that way, right? But we're going to have a common set of code that does this, right? So what does this look like? Well, first you start off with your strategy interface. This defines the common interface that all the algorithms support, right? And then you have your concrete strategies, right? So these are your different strategies. Each class represents a different behavior, a different algorithm that needs to happen. And then finally, you have your context, right? And this is basically what needs to benefit out of this strategy, right? So in code, again, you have your strategy interface, so apply discount, all right? I think the code will help make this more sense, right? So here, so I run a store and we want to apply discounts based upon different conditions, right? So we have our strategy interface. Here we have our strategies, and this is 3 different classes. So the first class, I'm saying there's no discount, right? Apply discount, and basically I just give you back the price, right? But then I have my seasonal discount, and so my seasonal discount would be, multiplied by 0.9, right? And then finally, multiplied by 0.85 if it's a loyalty discount, right? So again, we can apply these different types of strategies. So in my context, I have my price calculator. It takes in what type of discount strategy to use. So, we receive this order in here. Hey, this is, it's springtime, so we need to give them the spring seasonal discount. Or, hey, this guy spends a lot of money with us, so give him the loyalty discount, that type of thing. So you can see we apply the appropriate strategy. And then finally, implementation. There's a lot of code here, but it's really simple. It's just because I'm showing each one of the patterns here, or each one of the strategies, But the point is, I know what type of strategy I need to use, right? So there is a little bit of coupling there. But, I say, hey, use this strategy, and then provide me that price. Some common examples in .NET, dependency injection and service lifetime. So here's a perfect way to think about this, right? So you configure your services, add transient, add scope, add singleton. Well, those are strategies, right? They're defining different ways how I'm going to have that dependency injection done, right? No matter what, I'm adding the service, but I'm saying, hey, use this strategy, right? So only ever allow one of this object, right? Or only allow this, per user scope type thing. Other examples, logging, right? So here, again, we add that logging. So add console, add debug, add event log, right? So that's adding strategies, right? In this example, this is kind of a mix of a pattern, right? But it's adding strategies in here. Caching, right? So here you can see, the first one I'm saying, add distributed memory caching, or add Redis, right? To do all that kind of stuff. All right, so some benefits. Well, number one, again, flexibility and reusability, right? So now let's say so we have those three price discounts. Let's say we also have a military discount. Well, no big deal, right? All we have to do is add another strategy to handle that. Especially maybe there's multiple levels of that strategy, right? Again, the code examples I showed, you would not want to use a strategy pattern for as simple as that code design I built for the example. But think about where it gets more complex, right? It's great for that. It eases the maintainability, even though you're adding more code out there, but your code is single focused, right? And so it makes it easier. I know exactly where I need to go, right? Oh, I need to do work. We're going to make changes to how seasonal discounts apply. I know exactly where I need to go. It's going to go one piece of code. The dishwasher started. So ease of extension, right? Because again, it makes it really easy to extend that. It simplifies testing and debugging because again, in there I can just call those strategies and I can test those individual strategies. And then finally, I get that runtime flexibility, right? Because at runtime, I can make the decision what type of strategy to apply here, right? I don't have to have a lot of a pre-built logic in there. I can, at runtime, I say, oh, this guy's a military vet, so give him that military vet discount type thing, right? So some great benefits, some drawbacks. Well, while I said this is part of the maintainability, but also you are adding more classes, right? So your project's getting bigger and bigger, right? So you've got that type of thing, which does add to your code complexity. It has a tendency to couple your context strategy, right? Because now your context needs to know what the strategies are, right? At least it needs to know the strategies that it cares about. So, again, you've added that coupling. But again, I think this is one of those times when coupling makes sense. Your client needs to be aware of what's happening, at least to an extent. Again, he needs to know which strategies to apply and when to apply those, right? So your client has to be aware of that. Again, your performance overhead, that's in all these patterns, right? So things to consider when you rebuild it. As far as times used, sorting algorithms is a perfect example, right? So think about, okay, well, I needed to do a bubble sort, or I needed to do a merge sort or a quick sort, right? Again, I can apply those different strategies right there. It's a perfect example of using this. Your payment processing systems, right? Oh, this is a cash transaction. This is a Amex transaction. Again, apply those different strategies that way. File compression, authentication mechanisms, right? A lot of times, think about, oh, they're coming over Twitter or X or whatever it's called today. They're coming over Facebook. They're, again, the different OAuth type methods. Your log formatting, right? So some great examples of when to use this. Times when it's not so great. Again, it's simple, or static behavior, right? It's not going to change a whole lot. You need for simplicity. Again, the strategy pattern was meant for more complex type things, right? So if it's really simple, then it's probably more sense to put your code in there. You have a single use case. Well, then you're wasting your time. With that being said, you might know I only have a single use case today, but I know, maybe my MVP, I only have one type of strategy, but I do know, then it might make sense to go ahead with this. But, but with that being said, I've heard many, many times, well, we know we're going to use this. And then 10 years later, they never use that, right? That does happen all the time too. And then finally, if you have a lot of changes in your strategy logic, that could be a time to think about, whether or not to use this. All right. So a couple closing thoughts before we get out. Number one, careful consideration. So the reason why I talked about the benefits and the drawbacks, right, is because everything has, nothing is perfect, right? Nothing meets every single use case, right? So the things we have to consider. Number one, we should apply them judiciously. So, and here's one of the things. So the company I work for now, right? Actually, I just reached 6 months. But when my final interview with them, they were showing me a presentation of what they were building, and and the architect he listed out like I swear it felt like 18 different patterns, and all I could think is like, okay, are you applying patterns just to apply patterns, or are you really using all these patterns? Right? We have to really think about what patterns we're applying. Does it make sense? Right? Is it appropriate to use in what we're building? Right? Again, if we're building something very, very simple, right? Some of these patterns don't make sense because they require a lot more code. And again, we have to think about those trade-offs, right? Think about, are we really doing all this kind of stuff? I mean, it really boils down to, just think about it before you use. And to the point, I have a whole, and I mentioned this earlier, I have a whole talk. And actually, I talk about the observer pattern, and I talk about the factor pattern, I talk about a couple other patterns, right? So some of the patterns I talked about that are essential to know, you also have to watch out for, right? Because they can cause issues. I was going to say, if you want to go to Grand Rapids or to St. Louis, you can hear me do that presentation. All right. So the other thing to think about, so we talked about creational strategy, structural and behavioral patterns. A couple other different types of patterns to think about. So we talked about these three. So there's concurrency patterns, right? So these, your thread pool, producer, consumer, reader, writers, right? So how do we deal with concurrency? How do we deal with multiple things need to happen at the same time, right? So that's different types of design patterns. Architectural, right? So, MVC, event-driven architecture, microservices, service-oriented architecture. Hopefully no one's dealing with that anymore. But these are architectural patterns. They're more higher level, right? They're composed of a bunch of design patterns inside of them. But important to understand. And then finally, you got your cloud patterns, right? As we build more and more stuff out in the cloud, we've got all these different type of patterns that we apply in there. Sure enough, I have to talk about that too, right? I'm sorry, I don't really mean to bitch myself, but go to this one. That's in Germany. Come join me in Germany. That's actually a great event, and it's in Berlin, right? I mean, why else? Why would you not want to go to Berlin for an event? All right. So in summary, we talked about the overview of design patterns. The fact that they provide that common use cases of how to build your software. We talked about the builder, the factory. So we talked about these different type of patterns. And again, the important part, consider the benefits and the drawbacks as you're looking at these. Make sure that what you're applying makes sense. And then finally, I talked about other creational patterns. So again, definitely, join me. I'm going to be at a bunch of different places. Probably, I think API conference and serverless conference, that's the coolest one because that's Berlin. I am going to be speaking for what do they call it? Basically, the .NET conference in Rome, but I'm doing it virtually. I don't actually get to go to Rome. So it was good news, bad news. I was like, all right, well, I'm still going to be talking a bunch of Italians. But yeah, definitely some great events. So with that, any questions? I mean, I kind of sped through this a little bit. Not bad. I mean, I still did it in less than an hour and a half, so that's not too bad. But any other questions? Well, also, I mean, there's all my contact information. I'm easy to get a hold of, and hopefully you'll join me over at Brick House. I can never remember the name of that. No, it's not Brick House, is it?
Brick House Tavern.
Okay. See, you know why I always mix it up? Because Brick House is also, who sings in the house about how she's a brick house? Yeah. Look, I'm an old guy, okay? What can I say? All right. So with that, like I say, thank you. Thank you so much for everyone online. Thank you. I think I didn't miss any, or pretty much, yeah. Just looking over the comments online. So everyone online, thank you so much. I'm going to go ahead and stop the stream there. Great.